All right. Now let us discuss about the rest of the key processes which are extremely relevant from the functionality of Tableau desktop and Tableau server perspective. Let us first discuss about the data engine. Tableau Data Extract TDE Server 64 is for a 64-bit server. And if you have installed a 32-bit server, as in our scenario, this is a process that is pivotal for us. It is going to store all the data extracts and answer the queries. This data engine might get queries or requests from a SQL server. It might get the queries from application server, API server, application programming interface, just in case you want to know what API stands for, application programming interface. Data engine process services the request from data server, background server, so on and so forth. And not just these, data engine is going to service the request from most of the other server processes as well. It is the component that loads extracts of the data into memory and perform the queries against them. For example, if you're extracting the data from SAP into Tableau server, then this data engine would play a pivotal role, right, in extracting this data from SAP into memory. And whenever you try to query the data from Tableau desktop, see, this is your Tableau desktop. When you try to query, you'll be referring to this data, this extract. And this is where your data engine plays a key role. And this data engine is multi-threaded. When I say multi-threaded, I mean that this particular data engine process can perform or handle multiple requests at a time, as opposed to our cache server, which is single threaded, and also our background of process is single threaded. So that means they can handle only one request at a time. And it also has a lot of load on the system resources, on your server resources, including your CPU resources, your input output operation resources, and your network resources. And hence, we should be very cognitive of how to use the data engine, how many processes we need to run, so on and so forth. And if you have very high loads of data, say you have millions of records of extracts, in such a scenario, a single instance of your data engine might try to utilize or consume all your CPU resources to process the specific request. Hence, it is very important and pivotal for us to configure the right number of processes of data engine. When it comes to a data server manages the connection to Tableau server data sources. So if you are extracting data from, say, Oracle into your Tableau server, then your data server would act as a proxy. And it is normally only bound to your network resources, but it can be bound to your CPU resources as well, depending on your how many users are accessing your Tableau server simultaneously. Its load is generated by browser. So if you have a web browser, say you have Google Chrome or Safari or Firefox or any of the browsers, and if you're trying to access the visualizations in your browser, that is when this process data server would get loaded. And it gets loaded when you are having extract refresh jobs for Tableau server data sources. Say from Oracle, you have extracted the data and placed in your Tableau server, and say you have done it last week. In this week, probably there are new additions to your Oracle database. And if you want to update your extract, you would obviously not be extracting the complete database once again. Instead, from last week until this week, whatever changes have been done, those changes would be loaded onto your Tableau server. And this is called as incremental refresh. Incremental refresh, basically. All right. So this is the use of your Tableau server. Now let us discuss about the file store in a brief explanation. File store, this is the process file store or exe which runs behind the scenes. It automatically replicates the extracts across data engine nodes. What does that mean? If you have server A, server B, and server C, which are in a cluster, or if you have multiple instances running on a single server called server A, if you have multiple nodes or instances running on this server. And such scenario, file store comes in handy. File store, assume that you have a SAP database and you're trying to extract the data and store it on server A. This data which is on server A has to be available on server B and also server C. And the most updated data has to be available on server B and C, because if your server A crashes, you need server B or C to be able to handle, right? You want users to fail over to server B or C, and you want users who are failed over to server B or C to continue accessing your visualizations or reports, right? So normally your file store will always be present if there are one or more data engine processes, and it cannot be installed separately. We need to bear that in mind. All right, now let us discuss about repository. Repository, the process name is postgres.exe. Tableau server database stores workbook and user metadata. What does that mean? Your repository would contain the details of all the user's permissions. Say you have given a user read access, you have given another user editor access, or someone has changed the permission settings. All those details would be available as part of your Tableau server repository. It contains all of your logging information, server log file locations, right, which I'm going to explain in the next tutorial. Who is the user whom you have created? Right? What is the access that you have provided to that user? Have you created groups of users? Have you given them permissions? What is the extract metadata? What is the refresh information? All that information would be part of your repository. And each term that I've used now, such as creating users, groups, group assignments, permissions, projects, their sources, extracting the metadata, refresh information, all that would be discussed in detail in the subsequent tutorial. So you need not press the panic button yet. And when your failover happens, say you have server A and server B in cluster. If server A fails, your server B, which is called as your passive repository, will pick up. And this passive repository will become active if your server A goes down and if the failover happens onto server B. This passive repository would then become active. And it would remain active until your server A is restarted, or you need to forcibly use a command to switch back from using server B as your active repository to A using a function which is called as failover repository. All right. So I'll discuss more about this at a later point of time, but you can use tab admin. There is something called as tab admin. We're going to discuss this also later on. And you need to provide a function, failover repository, and run this function, run this command. If you run this command, your repository logging will change from server B to server A because server A happens to be your default repository. So this is how the logging happens. And let us discuss about the remaining two processes and then look into where we can find these processes and check whether these are running or not from the Windows machine perspective. All right. Search and browse is the next process. This process is memory bound first and IO bound second. So it will consume all of your memory resources, and if it has exhausted, then it will go to IO bound. And the amount of memory used depends on number of sites, number of projects, number of users, so on and so forth. This search and browse is going to handle fast search, filter, retrieval, and display of content metadata on the server. So if you're trying to filter, probably you have a field called region. And say you have east, west, south, and north options within this region field. You can filter and say that, hey, I want to view only east region. Right? Handling these kind of filters is part of your search and browse option. Last but not the least is a SQL server, which consumes noticeable resources during loading your view or interaction with the web browser. If a user tries to interact a specific view using a web browser, that is when your SQL starts using your CPU resources, your IO resources, your network resources, so on and so forth. And you can quickly run out of process memory. So you should be very delicate in handling with SQL Server, and there has to be a thorough rationale behind changing the default settings or default number of processes to be run using SQL Server. It loads and renders the views. It computes and executes the queries that you load. For example, if someone is trying to load a view, SQL Server process gets triggered. If you have 1 million records, and if you feel that calling all the 1 million records at one go would actually hamper the performance of the system, that is when probably you want to call only the 10 fields out of these 100 fields in 1 million records. 100 fields and 1 million records would be 100 million records in total. But if you want to call only 10 fields, then it will be 10 million records, considering that each field would have those many records, 1 million records. And that is where your SQL server comes in handy, and it is going to handle your execution of queries. Now, let me show you all a specific process window within desktop or Windows desktop rather, which would show you the list of all these processes pertaining to Tableau. For that, all we need to do is do a Control Alt Delete on your keyboard, which is going to come up with that window. So I've done a Control Alt Delete, and we need to go to the Task Manager, and this is your Task Manager. And this would contain all the processes basically pertaining to your Tableau. So let me scroll down. Post GRE SQL Server, you have that. You have MySQL drivers. A few of the drivers are installed by default when you install your Tableau server. You have Redis server, which we have already discussed about, which is nothing but your cache server, right? And you have all these processes, which we have discussed. We have Zookeeper process, right? We have data server, file server, so on and so forth. You have all these Tableau related processes, SQL server, tab admin server, so on and so forth. You can check whether your processes are running here or not. If you just see the names of the processes and do not see the corresponding names, all you need to do is right click and say you also want to view the process name. And if you check that option, you'll be able to see the process names also. All right. In the next tutorial, we will be discussing about how to view the log files, way to view the log files, both from your Tableau Server Administrator window perspective, browser perspective, and going and looking into that specific folder in program data. We'll be discussing about all that in a moment. Thank you so much for listening to this session.